I'm Jake O'Neill, creator of Animographs, and this is how the cockpit or flight deck of a jet airliner works. Some systems described here can be even better understood by watching our companion video, How an Airliner Works. This is a flight deck, which implies a bigger space with room to move or walk around, as opposed to a cockpit with just enough space for seats that pilots might climb into. Starting at the back wall of the flight deck, there are hat clips and the pilot's wardrobe closet. On the other side, there's a jump seat that slides and folds out. There's a crash axe nearby, as well as a flashlight, oxygen cylinder, and portable breathing equipment. Detailed circuit breaker panels are situated near the back wall on both sides. Seating. The pilot and co-pilot seats move back and to the side for entry. They have a 5-point harness and ample adjustments for proper access to flight controls, as well as comfort. There are heated foot mats in the floor. Eye level locators between the front windshields indicate proper seat position, ensuring optimal visibility for all flight deck operations. The ideal position is reached when the white sphere is completely hidden behind the front red sphere, as viewed by the person adjusting the seat. The armrest on the outside of each seat has tilt and vertical adjustment knobs for unobstructed arm mobility when using the side stick or tiller. There's a small step near the inside shoulder of each seat back for access to an overhead escape hatch. A compartment holds an emergency rope that flight deck crew can use to slide down the side of the plane. Side stick. A side stick controller on each side gives the pilot or co-pilot control over the roll and pitch of the aircraft. An autopilot priority switch disconnects autopilot if it's engaged. With autopilot off, holding the button gives this side stick priority. A pitch trim switch can set the auto trim rate for the horizontal stabilizer or allow manual trim adjustment in direct mode. There's a switch at the front of the stick for radio or intercom communication. Steering. While taxiing under 30 knots, a steering tiller can be used to turn the nose landing gear up to 80 degrees in either direction. In order to avoid damage to the nose landing gear, rotation is limited from 80 degrees down to 9 degrees max as speed increases from 30 to 100 knots and above. Rudder pedals can be used at any time to rotate the nose landing gear, but are limited to the maximum 9 degrees. In the past, the flight bag at each seating position held airplane-specific operation manuals, navigation charts, checklists, and so on. Electronic tablet devices have replaced most of these items in recent years. Some airplanes may also have a head-up display, allowing the pilot or co-pilot to view relevant real-time information like runway alignment, airspeed, altitude, and more. Rudder pedals. With feet in the lower position, rudder pedals move forward and back for rudder control. Moving feet to the upper position allows pedals to rotate, engaging left and right main landing gear brakes. A mechanical linkage ensures the pedals on both sides move together. Pilots can adjust the pedal position with a knob at the front. Control panels. Now, let's have a look at the control panels, starting with the overhead panel. Many of the switches in these panels have lights that convey important info, something like the warning lights in a car's dashboard. However, unlike simple car warning lights, when pilots interact with these switches, their lighting status can update. A fire module sits in the center. The switches glow red when a fire is detected. Some of these switches are protected with doors that must be flipped open for access. Pressing a fire switch helps mitigate fire spread and damage by shutting off fuel to the respective engine and arming fire extinguisher bottles, among other things. Once armed, nearby switches discharge specific fire extinguishing bottles when pressed. Let's move to the left outboard module. Starting at the back, the entrance knob and dome switch control flight deck lighting. The protected aural warn switch allows the audible warning system to be silenced if there's an issue with the aural system. This system handles the many warning sounds and phrases that alert pilots to critical events. Window heat and probe heat toggle de-icing functionality for windows and external temperature measuring devices or probes. Primary flight control computers can be individually disabled using any of these three protected switches. The CVR section handles the cockpit voice recorder, which records not only sounds inside the flight deck, but also all connected audio channels, both internal and external. The next panel section has knobs to control lighting brightness for circuit breaker panels, overhead panels, the compass, and more. Turning this knob to the storm setting illuminates the complete flight deck, all panels and dome lights to maximum intensity. The next panel controls communication during plane servicing. With the service intercom switch on, all flight deck and service intercom channels are opened. The call button sounds a horn in the external service panel area. At the end of this module, there are captain's side reading light and windshield wiper controls. Now let's move to the left inboard module. The hydraulic section has controls for various hydraulic system scenarios, since there are 3 separate hydraulic systems in the plane for safety and redundancy. This panel allows various configurations so these systems can work as normal or supplement each other in varying conditions. The electrical section has a knob for various electrical system scenarios. For example, the ESS setting powers only essential systems. The guarded switch next to this knob turns off power to select cabin systems, which can be useful for isolating sources of smoke in the cabin, whether from electrical arcing or some other source. The guarded RAT switch allows flight crew to manually deploy the ram air turbine, or RAT. Under normal conditions, the RAT will deploy automatically if power is lost in flight. Battery knobs control onboard battery packs 1 and 2. The left and right gen switches toggle engine-driven electrical power generators. Each has a protected disconnect switch to disconnect the generator shaft from the engine if, for example, leaving a malfunctioning generator connected could lead to engine damage. The APU switch can disconnect the auxiliary power unit from the system in case of an electrical fault. The EXT switch allows crew to toggle the external power connection. The APU pull-turn switch functions something like a car ignition. The start setting is held for 3 seconds to start the APU. Once started, the switch reverts to the run position. The APU fail light illuminates for any electrical, fire, or starting issues. The terrain awareness and warning system has protected switches to turn off aural warnings associated with landing gear, terrain detection, and flaps. The GS switch turns off aural warnings related to glide slope, which is the pre-calculated path of descent in the flight control system. Moving to the right inboard module, we see the fuel subsection. With the manual transfer switch in off mode, the fuel system functions as normal. The other settings allow flight crew to select specific fuel tank configurations. Left and right boost pump switches control supplemental, electrically powered fuel pumps, where the system under normal operation relies on engine-driven pumps as the primary source of fuel pressure. The gravity transfer switch opens valves so that the fuel can move between tanks by gravity alone. The air section has climate controls at the top, and also ventilation settings for cargo compartments. The trim air switch toggles valves that allow air from the engine bleed air system into the climate control system. When the pack flow switch is active, the air conditioning units, or packs, enter high flow mode, which can be useful for clearing smoke or odors. There's a switch for recirculating air fans. The guarded ram air switch can open external ports at low altitude for flight deck or cabin ventilation. Left and right pack switches grant manual control over air conditioning packs, which otherwise operate automatically based on desired climate control settings. Cross bleed, left, and right bleed switches grant manual control for engine bleed air valves and APU bleed air. The anti-ice section controls de-icing capabilities in the left and right engine cowling and wings. Right overhead module. The ELT, or Emergency Locator Transmitter, pull turn knob can test and arm the ELT. The cargo section handles fire reporting and deploying fire extinguishing bottles in the cargo areas. Equipment cooling refers to cooling systems for equipment bays. The inlet switch controls cooling fans and an external valve to take in outside air. There's also a switch for exhaust air produced by the equipment cooling system. In the pressurization section, there's a guarded switch for emergency depressurization of passenger and flight crew areas. The auto press switch allows manual pressurization control, which is usually an automated process. In manual mode, the dial beneath sets the pressurization rate. The guarded ditching switch activates a ditching sequence. Ditching is a controlled emergency water landing in an aircraft not designed for such. The ditching sequence closes all valves below the aircraft flotation line, except for the ram air valve. The pack's oxy switch deploys passenger oxygen masks. At the end of this section, there's a switch to toggle the evacuation horn, and a pull-turn switch for evacuation lighting. Beyond that, we see the co-pilot side windshield wiper and reading light switches. Lights overhead module. Starting from the pilot side, there are external lighting control switches for navigation, beacon, strobe, and logo lights. The landing light section has a taxi light switch and special switches with triple LED indicators for left, right, and nose landing gear lights. A pair of switches in the PAX lights section control the seat belt and no personal electronic devices warning signs in the passenger cabin. Glare shield. The glare shield control layout is mostly symmetrical side to side. Starting at the captain's side, the two leftmost dials control brightness for main displays 1 and 2 beneath. The chrono button controls a basic stopwatch type function, which can be displayed on the primary flight display. The warning caution master switch shows a red warning or yellow caution alert if either are triggered. The switch must be pressed to acknowledge the alert and rearm the system for any further alerts. Pressing the side stick button gives priority to the pilot's side stick and deactivates autopilot. An RL priority left message sounds. The next cluster of buttons is a non-verbal system to supplement pilot's communication with air traffic control. There are options to accept, stand by, reject, or load pre-programmed messages into the flight control system, which can then be quickly accessed in communicating with air traffic control. The radio and control tuning section has knobs and buttons to quickly change displays for relevant info, and a radio panel with many related functions. The left and right buttons correspond to the left and right sides of main display number 2 beneath. The map button displays the last selected map type, of which there are various options. An adjacent knob adjusts map range. The FMS button displays flight management system details like position, flight plan, performance, route, and more. The CNS button opens screens related to communication, navigation, and surveillance capabilities afforded by the many special antennas and systems on the craft. The checklist button opens the electronic checklist. SYN opens synoptic pages, which are simplified real-time diagrams of critical systems, showing, for example, the status of the hydraulic or fuel system, and major components at a glance. Data displays the last selected data page, which can be items like important documents or aeronautical charts. Terrain, traffic alert, and weather switches bring up overlays corresponding to those systems. The baro switch changes how barometric pressure is displayed. The small screen has surrounding buttons for quick access to features that affect how items are displayed on primary screens below, including weather radar, navigation details, and so on. The Tune menu button and dial are also for navigating settings and menus on this screen. Ident broadcasts aircraft identification to air traffic control for 18 seconds. The flight control panel sits at the center of the glare shield and is used to input and monitor flight data in the automatic flight control system. The FD switch displays pitch and roll commands from the flight guidance system on the primary displays. The SPD switch selects between various ways of measuring airspeed and how that info appears on nearby flight control displays. The HDG button displays heading on the flight control display. The dial tunes to the desired heading, which is an angular measurement from north at 0 degrees, clockwise, to 359 degrees. Nav selects between various available ways of measuring lateral or side-to-side movement as the aircraft travels its flight path. The approach button selects between various approach systems, where airplanes and airports have different available equipment setups. Aircraft can choose to rely on their own data for airport approach, or some blended procedure where airports have systems in place to relay precision guide information to the craft. The half bank switch limits bank angle in a turn, especially at higher speeds, to avoid uncomfortable G-forces on passengers and crew, and to mitigate the likelihood of a stall. Switches in the center of the flight control panel deal with autopilot and related functionality. The AP switch toggles autopilot. AT toggles auto throttle capability. The XFR or transfer switch determines data channels and sensors used for the flight director system. The guarded EDM switch activates emergency descent mode and is not, in fact, a special guarded switch to play electronic dance music for impromptu sky raves. On the co-pilot side, an FLC switch determines how flight level change is maintained. Pilots generally select to maintain horizontal airspeed for climbs, but vertical airspeed for descents. The Alt inner dial sets the desired altitude, and the outer dial sets measurement in feet or meters. The Alt switch holds the aircraft at its current altitude. The VNAV, VS, and FPA switches are different modes to auto-calculate pitch commands. VNAV uses data from the flight plan. VS uses desired vertical speed to generate pitch commands, which the crew can set using the nearby dial. The FPA switch uses a desired flight path angle, which can also be set with the dial. Main instrument panel. Large interchangeable screens can be customized to show things like flight parameters, navigation and communications info, approach and weather charts, synoptic pages for critical systems and component status, electronic checklists, maintenance data, and more. A small integrated standby instrument in the center can supply necessary info to fly on emergency power with no other available displays. It has nearby buttons and a dial for customization. Landing gear and brakes. The landing gear lever extends or retracts landing gear and must be pulled out to operate. In the event of a malfunction, the guarded alternate gear release switch electronically disengages uplocks, so landing gear can naturally free fall to the down and locked position. The guarded gear aural switch mutes the gear aural warning. The auto brake switch has settings to maintain a constant deceleration during landing. The RTO setting controls braking for a rejected takeoff scenario where the plane has to stop on the runway instead of taking off. The The protected alternate brake switch grants full manual brake control without automated braking assists. The nose steer switch toggles nose wheel steering capability. Center pedestal. The center pedestal is situated between both pilot seats and houses various systems input devices and controls for throttle and flight control surfaces. Starting towards the front of the plane, there's a keyboard for interacting with the flight management system and display screens. The buttons along the top are connected to the flight management system as well. The message button displays relevant system alerts. Route opens the pre-programmed flight route. The direct-to-dialogue button offers a streamlined way of changing or adding waypoints to the flight plan. The departure arrival button shows the respective flight plan info depending on the phase of flight. Beneath the keyboard, there are more buttons for flight system access. Map shows a map and flight plan overlay. FMS opens flight management system settings. CNS shows a communications and navigation screen. The checklist button shows relevant checklists. SYN brings up synoptic pages. Data can show charts, video, docs, and database info. CAS can show or hide messages from the Engine Indicating and Crew Alert System, or ICAS. This system monitors many critical engine processes. The cancel and execute buttons in the top right can approve or cancel flight plan modifications. The trackball-style mouse and surrounding buttons and knobs provide robust interaction with the flight management system and display units. There are buttons to select which display to interact with, a stacked knob for scrolling through lists and settings, and push-to-talk buttons at either side of the palm rest to open communication through selected transmit channels. The audio control panel handles the many available radio communication channels. Call buttons along the top let the crew select which antenna to use for broadcast. Very high-frequency antennas are best for line-of-sight communications and can be blocked by buildings or mountains. High-frequency antennas can penetrate some obstacles but are prone to distortion from atmospheric conditions like solar flares, geomagnetic storms, and so on. SATCOM is the satellite communication channel that may be ideal in places with limited VHF and HF equipment. CAB opens communication between pilots and flight attendants in the cabin. Volume switches pop up to activate respective listening channels. Pilots can listen on any number of channels. The PTT and INT rocker switch selects between external communication and internal channels reserved for communication between pilots or to ground crew. The next three dials let pilots listen in on various radio beacon and guidance systems that transmit info to the aircraft. Many of these channels transmit in Morse code. ID is a constant three-letter broadcast. Voice allows voice transmissions through this channel. Nav 1, 2, and 3 are channels related to flight management systems and usually transmit audio for specific airport identification, among other things. DME is the distance measuring equipment channel. MKR is the marker beacon channel, which aircraft can use to determine distance from a selected beacon, usually located along runways. PA is the public broadcast channel that lets crew broadcast to passengers in the cabin. The trim control panel has a split aileron trim switch that's spring-loaded to the center position for adjusting aileron trim. The surrounding LWD and RWD labels stand for left wing down and right wing down respectively. The rudder trim switch is also spring-loaded, and the surrounding labels indicate nose left or nose right. The reversion switch panel ensures critical info will appear on displays, especially in the event of a primary flight display failure. The display switch has 3 set scenarios to quickly switch certain digital info panels to particular displays, based on which displays are still available. The inhibit switch disables display tuning customization. The flight director and auto throttle alternate source switch changes which channel this data uses from multiple available channels, again for redundancy. The left and right cursor inhibit switches disable the respective trackball and buttons. Left and right primary flight displays control respective display screens. ISI is the small display in the center. The ADS switches let crew cycle through info from various sources in the air data system, like air temperature probes, angle of attack sensors, and so on. IRS switches cycle data from internal reference units. These units have accelerometers and laser gyros to measure things like aircraft altitude and heading, among others. The park brake pull-turn switch sets the parking brake. At the back of the center pedestal, there's an interphone that can be used to communicate with passengers or other flight crew. An onboard paper printer is situated behind a thin slot in front of the interphone with its associated buttons. Pilots may print out things like weather information, clearances from air traffic control, and performance numbers for takeoff. Multifunction spoilers can be extended with the flight spoiler lever in direct mode, though like other systems, spoilers often function automatically as directed by the flight control system. The slat flap lever has a release handle on top to advance past gated positions 2 and 4. There's also a protected deploy switch to override the system and force deploy slats and flaps to position 3. The engine panel has a switch for continuous ignition. This setting is generally automated but can be manually toggled by crew. Continuous ignition guards against engine flameout due to various events like heavy weather or turbulence. The start switch in auto mode lets the engine start sequence be directed by automated systems. Left or right crank lets the crew dry crank the engine or crank engines as part of a manual start sequence. There are fire indicator lights for left and right engines. The pilot event switch, when pressed in, marks flight data recorder info for future maintenance investigation. Throttle quadrant assembly. Switches at the base of the throttle quadrant assembly initiate the left or right engine start sequence. Throttle levers for each engine reach maximum throttle as they move forwards. Finger pull levers on the front of each throttle lever allow rearward travel into the thrust reverser section. A button on the side of each lever toggles auto throttle on or off. Toga switches at the side toggle takeoff or go-around modes. Takeoff mode increases throttle for takeoff based on automated flight plan data. Go-around mode is an alternate automated throttle process to maintain flight, for example, in an aborted landing scenario. The co-pilot side has some of the same modules as the pilot side with the addition of a lighting panel and the cockpit door panel. The stacked display knobs control brightness for various displays. The integral stacked knob controls lighting brightness for many panels in the flight deck with its outer ring, and glare shield panel brightness with the inner knob. The flood switch controls instrument panel floodlights. In the cockpit door panel, left and right buttons toggle display for surveillance cameras on the other side of the door. The unlock button unlocks the door. There's a keypad just outside the flight deck door with an emergency code that crew members may use to force unlock the door after a time delay. During the time delay, the red switch on this panel can deny the emergency open request.